Hi guys, lab 3 is about different valves. You know valves are used for either stop or control the flow. We have basically two types of valves. One is isolation valve and the other one is throttling valve. And we also have the different kind based on the fittings and also based on the application. For example, we have unidirectional valves or check valves and also safety valves. Today I'm going to show you the characteristics of different valves. The first valve I'm going to show is about gate valve. You know that gate valve, there are, as I said before, there are isolation valves and throttling valves. Isolation valves are for either fully opening or fully closed position. The valves will be either on fully open position or fully closed position. Or in other words, it will be 0% or 100%, either fully open or fully closed. Okay, the first valve I'm going to show you is gate valve. You see, here the main isolation element is the disc or gate. You see, as I turn around, see, I'm turning it anti-clockwise to open it. See, when I turn anti-clockwise, it is being opened. You see, this is the gate that is being opening. Okay, it's a slow opening valve, and this is used for isolation. And also at the same time, this valve is rising stem type. See, whenever the valve is open, you can see the stem rising upwards. That's so the name rising stem valve. From outside, you will be able to tell whether the valve is open or closed by looking into the position of the stem. If the stem is up, it is open. If the stem is down, it is closed. Okay, and you can see that this is fitted to the pipe by means of flanges. So the fitting is flange type. This is a flange type connection, and this valve is isolation valve. Okay, the stem is connected to the disc, and the movement of this hand wheel makes the valve open or close. Okay, this is one of the widely used isolation valves in oil and gas industry, gate valve. Okay, the next type of valve is ball valve. Here the main isolation element is ball. You can see the ball. Now it's fully open, and now it is fully closed. It's unlike a gate valve, this is a quick open valve. See, by quarter turn you will be able to open it fully. See, when the handle is in parallel to the line of flow, it is in open position. Whenever it is being perpendicular to the line of flow, it is fully closed. See, this is also an isolation valve, which is a quick opening valve. By quarter turn, you will be able to open it fully or close it fully. See, from outside, you will be able to tell the position of the valve. See, now it's perpendicular to the direction of flow, and hence it is closed, and when it is parallel, it is open. Even though it is used as isolation valve, in some case in industry, sometime it is used as a bypass valve, you know, because it has got limited throttling ability as well. But it will not give that much 100% throttling, but it is used as a throttling valve as well in industry in some time. Okay, that's why it is used as a bypass valve. Normally it's a isolation valve. The next isolation valve is a plug valve. This is the plug valve. Here the main isolating element is a plug, but normally there should be a handle, but the handle is not over here now. Here also, like a ball valve, the handle, if the handle is in line with the line of flow, it is open position, and if it is in perpendicular, it is closed position. This is also a quick opening valve because the quarter turn or 90-degree turn will make it fully open, and it can make it fully closed if you turn backwards 90 degree. Quarter turn will make it fully open or fully closed. So it is a quick opening valve. The speciality about the plug valve is it can be used for very high pressure application. As you can see that the plug is very strong and it can be used for very high pressure application. This is also a flanged connection over here. Okay. Now we have seen 3 isolation valves: gate valve, ball valve, and plug valve. See, another type of gate valve is non-rising stem. Come over here. This is also a gate valve, but the speciality about this one is, whenever I open this one, you can see that the stem is not going up. It's a non-rising stem valve. From outside, you will not be able to tell whether it is open or not. But you see, this is a non-rising stem, whereas this one is a rising stem, because whenever you try to open it, the stem will go up. Here, the stem is not going up. But you cannot see it outside, from outside. The hand wheel is moving, but you cannot see the stem going up or down. Okay. Next is throttling valve. Throttling valve or regulation valves can be used for opening from 0 to 100%. See, that means it can be open 10%, 25%, or 30% to 50%, and so on. Whereas isolation valve normally 0 or 100%. This one 0 to 100%. See, here also the regulating element is the butterfly. See, you can see this is why butterfly disc. See, this is also a valve which can know the position from outside. See, the position of the valve. See, if it is in line with the flow, it is fully open, and if it is if it is perpendicular to the line of flow, it is closed. See, it's a regulation valve. It cannot be used as isolation valve at all because it will not provide a tight shutoff in a fully closed position. The next regulation valve is diaphragm valve. Before that I will introduce you to the globe valve. Globe valve is one of the most commonly used regulation valves. You can see that one. The regulation element is like a disc over here, or it's called globe, but not in the globe shape, but this is called the globe valve. You can see that one. Okay. Normally we use anti-clockwise turning to open and clockwise to close it. This is globe valve. Globe valve is a regulation valve. Normally for globe valve, it will indicate the direction of flow outside the valve body. If you look into the valve body, it will be showing you the direction of flow or the direction at which it need to be installed in the pipeline. Okay, the next isolation valve is diaphragm valve. Here the regulation element is a diaphragm. You can see the diaphragm. The movement of diaphragm opens or closes the valve. You can see this one. This is the diaphragm, and as I move the hand, it opens, and the contraction, the expansion and contraction of the diaphragm will make the valve open or close. The speciality about diaphragm valve is about this material, because it can be used for chemical or handling chemical or corrosive fluids, because this diaphragm will not allow the fluid to come in direct contact with the valve body. That's why it is used for special application like for handling chemical or corrosive fluids. This is also a throttling valve. Now we have seen 3 isolation valves and 3 regulation valves. Isolation valves are gate, ball and plug valves, whereas throttling valves are butterfly valve, globe valve and diaphragm valve. Now we have another valve which is a unidirectional valve or one directional valve, which is known as check valve. You can see this is a thing. See, it will allow the flow only in one direction. With the force of the flow will keep it open. As based on the flow rate, this will go up and down. If the flow is reversed, it will not allow the flow to go through. So that's why it is unidirectional. It will allow flow only in one direction. So always there will be a marking on the external body of the valve in which direction it needs to be installed. There will be an arrow mark stating the direction of installation. This is a unidirectional valve or check valve, one directional valve. See, there is a flap over here. The opening of flap will make it open, or the movement of the flap. The flap is connected to a pivot arrangement over there. Based on the force of the flow, this will be opening and closing. In no case, it will not allow the reversal of flow. This is another control valve. Here you can clearly see the valve this element, regulating element over here. This is a globe valve, and here the actuator is here. This is the actuator. This is the actuator, and this is the valve. See, now as I said before, this can be, it will be operated. It's a pneumatically operated valve. Pneumatically operated means it operates based on the pressurized air, availability of the pressurized air. And here there is you can see a valve position indicator also, based on the movement of the regulating element. This will be showing whether the valve is fully open or fully closed, or whether it is in between. That can be clearly seen over here. This is the position indicator, valve position indicator. The last type of valve, the one what we are going to discuss, is about safety valve. This is the cutaway view of a safety valve. And so, as we discussed in the class, normally the safety valve, it's kept in a closed position by means of the tension in the spring, right? The tension in the spring keeps it at the set pressure. As soon as the pressure goes beyond the set point, what will happen? It will pop open and release the pressure. Here you can see the disc over here, and also you can see that here you can see the discharge port also over here. In addition, it has got a lever, hand lever. In addition, it has got a manual lever in case it's not being connected properly. In case if you need to operate by hand or manually, you can do it. You can release the pressure by lifting this lever.